All right, so welcome back to part 2. We are now on the back. And so directions, we're going to do some examples. Identify the following as permutations, combinations, or counting principle problems, and then solve them. So we'll figure this out. The big question to ask yourself for all of these, does order matter? So let's start with number 4. In a race in which 6 automobiles are entered and there are not ties, in how many ways can the first 4 finishers come in? So we have 6 people competing, 6 cars competing, but we're only going to choose the first 4. Now, we can assume in this case that if we do this, first place is different from fourth place. We have first, second, third, fourth. So in other words, the order matters. I want first place more than I want fourth. First is better. So this would be a permutation. We can just write P, permutation, because order matters in this case. Now if we want to think our way through it, we have 6 cars, so there are 6 ways to choose first place. Then there are 5 ways for second, and then 4, and then 3. And we always multiply those together. And that would give us 360 ways for the first 4 people to finish. It's not 6 factorial because they don't have us go all the way down to 6th place. We stop here. Now the other way we could have set this up, though, we could have said 6 objects. We're going to do a permutation of 6 objects, and we're going to choose 4 of them. So let's see if that gives us the same thing. 6 math permutation 4. And there you go. There's your 360 right there. So you can set up the blanks, you can think your way through it, or it might be easier to just set this up and then evaluate to get your answer 360. So that's a permutation. Suppose that 7 people enter a swim meet. So here's number 5. So we have 7 people. Assuming that there are no ties, in how many ways could the gold, silver, and bronze medals be awarded? So that means we're going to pick 3 medals, 3 people for medals. Gold is definitely better than silver and bronze. So order matters. That's a permutation, okay? Order matters. Now we have 7 people, so there are 7 ways to finish in gold. Then there's 6 people left for the silver, because one of them already has gold, and then 5 people left for the bronze, and we can multiply that. 7 times 6 times 5, and we get 210. But again, we could have done this a little bit simpler. We could have said permutation, 7 people, and we choose 3 of them. So we could have said 7 permutation 3, and there's your 210. So there are a couple ways that you can look at this. Let's take number 6. We'll do a couple more. 25 people work in an office together. So we have 25 people. 5 of these people are selected to go to a conference. How many ways can this group be selected? Now, going to a conference, it doesn't say whether those 5 are going to be different positions. In this case, we can assume that, okay, all 5 people are going, but it doesn't really matter what order they get chosen. If you get picked first, or if you get picked 5th, you're still going to the conference. So when we set this up here, since the order does not matter, we're going to say this is a combination. In number 6, this is a combination. Order does not matter. As long as you're going, again, it doesn't matter if you're picked first or last or third or whatever. So if you want to think about this visually, we're going to pick 5 people out of 25. So there are 25 ways to choose the first, 24, 23, 22, 21. So these are the 5 people we're picking, but since the order doesn't matter, we have to divide out the repetition. It doesn't matter if you're picked here or here. So since we are arranging 5 people, we're going to divide by 5 factorial. If we picked 4 people, we would divide by 4 factorial. All right, so now we'll calculate here. So 25 times 24 times 23 times 22 times 21 equals, big number, but then I have to divide by 5 factorial. And we get 53,130. It's still a lot. So 53,130 ways of doing this. But again, what would have been easier? Well, out of 25, we're going to do a combination and choose 5 of them. So 25 math, combination 5, and we get 53,130. Okay, so we're going to want to use this notation. It's just going to make things faster to do it. All right, let's do 7. The model of the car you're thinking of buying is available in 9 different colors and 3 different styles. Hatchback, sedan, or station wagon. Okay. In how many ways can you order the car? Now, this is a counting principle. This is what we were doing mostly the other day. Because we're choosing 2 things that really have no relationship to each other. We're going to choose a color and we're going to choose a style. But we're assuming these are independent of each other. These are 2 separate choices. So how many colors do we have? We have 9 that we can choose from. How many styles do we have? 3. And the counting principle says we multiply that and we get 27. So there are 27 ways to order the car. So don't forget about counting principle problems. So permutation, order matters. Combination, order does not matter. And then a counting principle is where your choices are totally different. They don't depend on each other. Let's do one more here. Let's go down to number 10, which has an A and a B. And I want to do this because we actually have both a combination and a permutation represented. Let's see if we can figure out which one is which. From the 30 pictures, okay, so we have 30 pictures that I have of my nephew's birthday party, my digital picture frame will only hold 3 at a time. How many different groups of 3 pictures can I put on the frame? So out of 30, we're going to choose 3. The question is, does order matter? Now, if you're choosing a committee, if you're just picking a group, if people are going to a conference, it doesn't matter what the order is. It does not matter. So this would be a combination. It doesn't matter, out of the 3 that I pick, if I pick one first or second or third, it doesn't make a difference. So that would be a combination. So I'm going to just type this, 30 NCR 3. And that's 4,060. So there are 4,060 ways that I can pick 3 pictures to put into my digital frame. Let's change it though, part B. Again, let's assume we have 30 pictures, we're going to choose 3, but now we want to fill the first 3 places with my favorite, with the best smile, and the best smashing of the cake. Now, each of these is different. My favorite picture is not the same as my best smile, and it's not the same as the cake smashing. So this time, order does matter. If I have A, B, and C, if I go A for my favorite and B for the smile and C for the cake, but then I switch it around and I say B, C, A, now we have 2 different arrangements that we have to count. So now it's a permutation because the order matters. So out of 30, we're going to do a permutation where we take or choose 3 of them. So we'll type 30, permutation. Now we're choosing 3, but the order matters, so we have a higher number of possibilities, 24,360. Now, for the rest of these that we haven't done, that's going to be your assignment. But for this, the nodes are complete.